Okay, so there's some different factoring techniques that maybe you have or have not seen before, but tends to be a little bit more complex and complicated. So, for example, suppose that you have the sum of two cubes, such as x cubed, and we'll say plus 64. Okay. Just to give you an example, you've learned that x squared minus 9, that factors to x plus 3 times x minus 3, because those are perfect squares. But if you have x squared plus 9, that does not factor to x plus 3 times x plus 3. This is a big mistake that people often make as they encounter these type of problems. They see x squared minus 9, they factor to that. They see x squared plus 9, they factor to x plus 3 times x plus 3. That doesn't work. If you take x plus 3 times x plus 3, you get x squared plus 6x plus 9. That's not x squared plus 9. Get my point? So it's important to think about like some of the squares. So like 1 is a perfect square, then 4, then 9, 16, 25. What are the perfect squares after 25? 36, 49. What's after 49? 64, 81, 100, 121, 144, 169, so on and so forth, right? Those are all perfect squares, right? We kind of get used to keeping those in mind. But it turns out that the sum and difference of cubes factor. And so it would be good for us to kind of think about cubes. You know, what are some cubes that factor appropriately? If you take 1 times 1 times 1, you get 1. So 1 is a perfect cube. What is 2 times 2 times 2? 8. So 8 is a perfect cube. Morning. 3 times 3 times 3, 27. 27 is a perfect cube. 4 times 4 times 4, see 4 times 4 is 16, times 4 more is 64. And 5 times 5 is 25, times 5 more is 125. And 6 times 6 is 36, times 6 more is 216. 7 times 7 times 7 is 343. And 8 times 8 times 8 is 512. Kind of tough to keep memorizing those after a while, isn't it? So we'll keep it on the smaller side, but I just want to be clear, folks. I would expect that you could remember up to 125. 1 and 8 and 27 are pretty straightforward, aren't they? After that, you just got 64 and 125. Those are perfect cubes, okay? So how do perfect cubes factor? I'll show you. This is the formula. A perfect cube factors to a binomial and a trinomial. Perfect cube factors to a binomial and a trinomial. And here's how it factors. What do you multiply by itself 3 times to get a cubed? What do you multiply by itself 3 times to get a cubed? Just a, right? What do you multiply by 3 times to get b cubed? B. Simple so far? If there's a plus sign here, there's a plus sign here. What goes for the trinomial? Easy. Square this. Square this. Multiply the two together. Do I have those? I've got this squared, I've got this squared, and then those two multiply together. That's all it is. This is always plus, and this sign is opposite that sign. So let's try factoring x cubed times x or plus 64. So right away you recognize it's the sum of perfect cubes because we've got x cubed and because we've got 64. So this tells me it's perfect cubes, okay? Everybody good? All right, let's factor it, okay? Binomial, trinomial. What do you multiply by itself 3 times to get x cubed? Just x. That was easy. What do you multiply by itself 3 times to get 64? 4. If there's a plus here, there's a plus here. Good morning. Square this. X squared. Square this. 16. Multiply the two together. 4x. This is always plus. This is opposite that sign. Factor. You okay with that? The difference of cubes is not that much different. We're going to factor 1 minus z to the 6th. 1 minus z to the 6th. Here's how the difference of cubes factors. What multiplies 3 times to get a cubed? A. What multiplies 3 times to get b cubed? B. Just like the top. What sign do you think goes in the middle? Subtraction, yep. The rest is pretty much the same. Square the front, square the back. Multiply the two together. This guy right here is always positive. This guy here is the opposite sign of that. Plus. So, let's factor this. Binomial, trinomial. What do you multiply 3 times to get 1? 1. What do you multiply 3 times to get z to the 6th? Z to the 2nd. Watch it play out. I can see some hesitation there. If we have z to the 2nd times z to the 2nd times z to the 2nd, we have z to the 3rd times z to the 3rd times z to the 3rd, and we'll just do z times z times z. So if I look at all those z times z times z, that's z cubed. Z to the 3rd times z to the 3rd times z to the 3rd, that's z to the 9th. Z squared times z squared times z squared, that's z to the 6th because we add the exponents, right? You see that? So it's z squared that we multiply 3 times to get z to the 6th. What symbol goes here? Subtraction. Very good. Some people say, does it matter if you put the z squared here or if you put it in front? It does matter. It matters a lot. You gotta make sure that you keep this first one there and this one there. We square the front. What's 1 squared? So the 1 goes there. I square the back. What do you get if you square z squared? Or what is z squared times z squared? Z to the fourth. I multiply the two together. 1 times z squared is z squared. This symbol here is always plus. This symbol here is opposite that one. Now let's factor. Have you seen factoring sum and difference of cubes before? Do you remember it from last year at all? Because we're kind of in different spots. Some years it gets covered, some years it doesn't. But especially if you're sitting in, coming out of a COVID year, like we didn't teach probably sum and difference of cubes in Algebra 2. We said we're going to just leave that out. There's certain things that get left out, but you want to make sure you see that as you maybe head on to a college math class someday. So we're going to do these two examples, and you guys are going to have time to work. Usually we do the other side too, but we'll do that Monday. We don't want to get too far ahead with all the people that are gone. We don't want to let Gavin get left out, do we? No. Okay, so we go to work. I see difference of cubes. Binomial, trinomial. What goes in these two spots here? I got an x and I got a 2 because it's minus. I subtract. What goes here? Yep, you square that guy. What goes on the end? 4. You square that guy. Multiply these two together and you get a 2x in the middle. This is always plus. The sign is opposite that sign. Factored. Now, you might get to a time where you kind of wonder, hey, does this thing factor right here? This never factors. This thing that you see right there, it never, ever factors, okay? I shouldn't say never. If it's a cube, it will not, I'll never give one to you where it factors, okay? There are some really complicated problems where this will end up factoring, but we won't look at those, okay? So you can just always leave that alone, okay? All right, we try one more. Oh, wow, this one looks difficult, doesn't it? Yep. But fortunately, you're extremely intelligent, okay? Because you're extremely intelligent, we can do this, no big deal. Just take it one step at a time. I see difference of cubes. I recognize that it's cubes because 3 times 3 times 3 is 27, right? And 5 times 5 times 5 is 125. Then b to the 6th, that'll be a b squared. C to the 3rd is c. D to the 9th is just d to the 3rd. Yep, so we see all cubes there. All right, so what do you multiply by itself 3 times? You get 27 b to the 6th. 3, and then b squared. Yep. 3b squared. What do you multiply by itself 3 times? Get the 125c cubed d to the 9th. Just take it one step at a time. What do you multiply 3 times to get 125? Got that 5. C cubed is just going to be c. And then d to the 9th is going to be d cubed. I see subtraction. Let's put subtraction. Take this and we square this. What is 3b squared? Squared. 3 squared is 9. And b squared times b squared is b to the 4th. I square the back. 5 times 5 is 25. C times C is c squared. And d to the third times d to the third is d to the sixth. Multiply these two together, and I get 15 b squared c d cubed. This symbol is always plus, and this one is opposite that sign. On cell factors. Okay. All right, so you can take out your homework. And that's partly, too, why I try to give your homework all in one packet right away at the beginning. So that way, if you are gone, you can work on it if you need to. Okay, so your homework should look like this. It's a worksheet that says factoring sum and difference of cubes, and it also says grouping. Grouping's on the back. That's what we'll do on Tuesday, okay? On Tuesday, we'll do the grouping. You guys can work on this front. You got 8 problems. I'll post that answer key. Congratulations to the girls' hockey team. I was there at the game last night. Me and Mr. Luther went. It was just up in Owatonna, just a couple blocks from my house. But they won a really close game. It was Dodge County dominated Albert Lee in the first period. I mean, the puck was near our net the whole time. And then, but it was 0-0. In the second period, it was very even. We had 7 penalties to their none. There was 3 times that we had two people in the penalty box, and it was a 3-on-5 situation. We stopped them. And we ended up coming up with a goal in the second period, go up 1-0. Then they got a penalty, and then we had the advantage. But it seemed like when they had the penalty, for whatever reason, even though they were 4-on-5, they were able to attack us really good, and they scored a really nice goal, tied 1-1, and then in the third period they took the lead 2-1 with about 6 minutes left, and it wasn't looking the best for us, but we came up with a big goal with about 3 minutes left, 2-2, and then in overtime, it was a scramble both ways, but they scored a goal and won 3-2. Lots of smiles, lots of tears. They went to state last year, although the competition was not as tough. The game they played last year against Austin, I think everybody knew that we were probably going to win. But last night, Dodge County, they lost earlier this season in Dodge County, I think 4-1. So they played hard. They were well represented. Dodge County were very good sports too. They clapped for them and gave them hugs, and it was a good game all the way around. So if you do see the girls, congratulate them, or send Mr. Goskison, Coach Goskison, an email and just say congratulations. So that's pretty exciting. So I've never taken a team to state before for track and field. Went to state as a team just about every year when I was in high school, but never done it with my team. I hope to do that sometime. Best track team we ever had was year 2020. We had about 23 returning seniors. Ginger Rui was a 45-foot triple jumper. He'd win all 4 events when he came out. We had other guys that were guy running a 202 in the 800. Had some pretty fast people. We had a 12-foot vaulter. That season got canceled due to COVID. Never had it. Thought we would have gone to state that year as a team, but we lost it. Next year we came back, we had 2 seniors on the team. We should be pretty good this year. They might not pick us to go this year.